Hello friends, welcome to this session. In this session, we will study the topic eccentrically loaded column. So we are studying the unit number 6, axially loaded column and eccentrically loaded column. So in that axially loaded column, we have studied in the earlier sessions. Axially loaded column means load is exactly acting at the centroidal axis and which produces the direct stresses, direct compressive stresses. So their effect onto the critical load on which the column will fail, that we have studied, but only one criteria we have considered, that it is axial type of the load. Means the load exactly, or concentrated load, it is acting at the center or at the centroid of that section of the column. The column may be circular, column may be rectangular, column may be square, or any type of the shape, but whatever the centroidal axis is there, that load is exactly acting onto the centroidal axis, right? So in this today's topic, we will study the eccentrically loaded column. So instead of the axial, the word is changed eccentric, right? Means the load is not acting at the centroidal axis, or load is not acting at the center of the cross section. That's why this particular word is there. Means the load is acting something apart, or some distance, some distance from the center, or some from the centroidal axis, so that it is called as the eccentrically loaded column. So whatever the cross section is there, the load is acting anywhere apart from the centroidal axis. That's why it is called as the eccentrically loaded column. And whatever the distance from the centroidal axis of the cross section of the column, that distance it is called as the eccentric distance. Okay, so and the total column, when we are study which is subjected to failure by this eccentric load, that column it is called as the eccentrically loaded column. I hope you understood, or the basic difference between the axially loaded column and eccentrically loaded column. So now in this particular session, we will more focus onto the eccentrically loaded column. Right. So let us start with the first slide. Yes, eccentrically loaded column. First of all, the term direct load. So already we know that direct load means the load which coincide with the centroidal axis of the column. That whatever we have talked earlier, that load is coincide with the centroidal axis of the column. That load it is called as a direct load. And the direct load produce the direct stress or direct compressive stresses, because our column is a compression member. That's why whatever the direct load which is acting onto the centroidal axis or along the centroidal axis, which produce the direct compressive stresses. Second term, second important term in this is eccentric loading. So I hope you understood the basic difference between the direct load and the eccentric load. So a load whose line of action does not coincide with the axis of the column or strut is called as the eccentric loading. So exactly opposite to the direct load, this definition is there of the eccentric loading, that load is anywhere. It is not along the line of action of the load, or line of action, that load is not along the axis of the column or centroidal axis of the column. It is something distance, something apart from the axis of the column or centroidal axis. That loading it is called as the eccentric loading. So that's why the line of action of the load is does not coincide with the axis or centroidal axis. It is called as the eccentric loading. And because of the eccentricity, or because of the eccentric loading, the column most probably fail due to buckling or due to bending. Okay, so first one thing you have to remember, that because of the direct loading, the direct stresses are produced, and column most probably fail due to direct stress, right? But in the eccentric loading, the column is most probably fail due to buckling or due to bending, okay, along the depth. So that's why, because of the eccentric loading, that column it is produced, it produce the buckling of the column. Okay, or buckling stresses or bending stresses are produced because of this eccentricity. Uh, so I hope you understood the eccentricity, that the line of action of the load is something distance from the axis of the column or centroidal axis of the column. Next important term is eccentricity. So we have a study about the eccentric loading, and now the eccentricity. Eccentricity is the distance. Eccentricity is the distance. How much distance is there from the axis of the centroid? That is called as the eccentricity. So it is nothing but the distance. So this distance between the axis of the column and the line of action of the load is called as the eccentricity. So which distance is there? It is the distance between axis and the load, where the it is a line of action where the load is acting. So that load acting on that point and the axis, centroidal axis of the column, whatever the horizontal distance is there, that distance it is called as the eccentricity. Okay, so it is a, by definition, if you have to remember, then the distance between the line of column and the line of action of the load, it is called as eccentricity. So in the coming lectures, or whenever we are solving some problems onto the eccentricity, we should know what is the eccentric loading and what is the eccentricity. Eccentricity is the distance between the two axes. One axis is the axis of the column or centroidal axis of the column, and other is the line of action of the load, where the load is acting, that point where the load is acting. So that line of action of the load and the centroidal axis, their horizontal distance, it is called as eccentricity. Okay, so it produces the bending stresses. So most probably the eccentric loadings are produce the bending or buckling stresses in the column member. Next, columns with the eccentric loading. So now in the figure you will clearly understand that where is the line of action of the load is acting. So in the figure you can see capital P is the load is acting, and there is a vertical axis is there, or which is called as the centroidal axis, and this load is acting somewhat distance from the centroidal axis. And what is the distance between this? So this distance between this is the eccentricity, and symbolically it is represented by small e. So in the figure you can see this is the total column whose breadth is there, and depth is given. There is a breadth and depth of the column is given D and B, and there is a axis, centroidal axis is given at the center, and capital P load is acting is somewhere any point onto the cross section of the column, and small e is the eccentricity, means it is a distance between the axis and the line of action of load. So you can see here P is the load, E is the eccentricity, B small b is the width of the column, D is the depth of the column. Now eccentric load causes direct stresses as well as bending stresses. So eccentric load produces both the type of the stresses many of times, that it produces direct stresses also in a small quantity, but it most probably fails due to bending stresses or buckling stresses. That's why it produces the bending stresses also and direct stresses also. Therefore total stress at extreme fiber is given by, so you can see, so how to determine the total stresses. So if whenever there is a eccentric loading is acting, the column is subjected to direct stress as well as column is subjected to eccentric, or column is subjected to bending stresses. And if you want to determine the total stress at the extreme fiber, so that we can determine by using this. So sigma is equal to sigma O plus or minus sigma B. So sigma O is nothing but direct stress and sigma B is nothing but bending stresses. So now we can put the values of direct stress and bending stress. So already in the earlier units we have gone through all the formulas of direct stress as well as bending stresses. So now direct stress is P upon A plus or minus. Bending stress is this from the bending formula. This quantity is taken, m upon I is equal to sigma upon y. So means sigma is equal to m upon I into y. So this m is the bending moment, I is the moment of inertia, and y is the distance of the extreme fiber. This is of the centroidal from the extreme fiber. So that is the y. Means this is exactly half of the width. Okay. So here you can see the extreme fiber or extreme face. So this is particular the one face which is extreme from the axis, centroidal axis of the column. This extreme face is the b by 2 at a distance. So this is the maximum distance of the extreme fiber is b by 2, either in this side or in the left side or right side. So that is the extreme fiber distance is b by 2. It's a maximum. Okay, most probably we have to finding out the stresses or bending stresses at the extreme fiber. Okay, means it is exactly half of the breadth. So now you can see the values are put here. Sigma is equal to P upon A. P is the direct stress. So load divided by cross section area plus or minus M upon I into Y. So why this plus or minus? It will depends upon the position of the fiber. Okay. So because from the axis in the whatever the position of the fiber is there, either left or right, that extreme fibers positions. So with respect to the eccentric loading. So depending upon that, we can take the plus or minus sign. Yes. Yes. Wait. Yes. After that, maximum stresses. So maximum stresses we can take, if you take the plus sign, we will get the maximum stress. So direct stress P upon A plus M upon Y into Y, right? So P upon A, so this M upon I into Y. So this is simplified here in the right side. You can see that bending moment is P into E, that is a load into perpendicular distance is the eccentricity. In the figure you can see this P into E. Let's see here. So this the load is acting, and if you want to determine the bending moment at the axis, so this load multiplied by the perpendicular distance is E, right? After that, uh, moment of inertia. So most probably the column will fail along the height or along the length of the column. So means our larger axis is IYY. So moment of inertia about YY axis, that is IYY, it is a dB cube by 12, and Y is the extreme fiber distance, that is a half of the breadth, that is a B by 2. Bending stress, if you put the formula that M upon I, so M value is P into E, I is dB cube by 12, and into Y, that is a B by 2. If you put all the values in the bending stress formula, so after simplification, after simplified this particular quantity, you will get the relation 6 PE divided by dB cube. So directly, that's why this bending stress is directly put into this total quantity M upon I into Y. That is a bending stress. Okay. So for your information, this calculation or this simplification, it is done here. So for the understanding, so you can directly take this bending stress value and you can put here. So now our formula is become P upon I A plus 6 PE divided by dB cube. If you take plus sign, you will get the maximum, right? And minimum. So here by printing mistake, you can take the minimum. If you take the minus, you will get the minimum stress. Okay. So there is a maximum and the minimum stress. So this sigma max, if you take the plus sign, and sigma minimum, you will take the minus sign. So that's it here. The eccentrically loaded column. I hope you understood the basic difference between the axially loaded column and the eccentrically loaded column. Because earlier sessions we have total studied about the axially loaded column, and in this session we have studied or more focus onto the column with the eccentric loading. So from the figure and the formulas are important, and based on this formula we will solve some of the numerical onto this eccentrically loaded column, right? So these terms are also important: eccentric load and where is the eccentricity is there, how to determine that direct stress and the bending stresses, their formulas. Bending moment is also important because there is the eccentricity is there. If your load is acting exactly at the axis, centroidal axis, there is a bending moment is zero at that particular point. If there is a eccentricity is there, definitely there is a bending moment is there, because there is a line of action of the load is distance apart from the axis or centroidal axis of the column. So that's why this extreme fiber, whatever the maximum stresses are acting, because on one face there is a maximum tensile stresses are acting, because our column is bent or column is failed due to bending. That's why on one face there is a tensile stresses are developed, and on the other face there is a compressive stresses are developed. That's why for any type of the phase we can determine the stresses which is developed, because most probably the column which is failed due to bending stresses. In the long column, it is failed due to bending stresses, and short column is failed due to direct crushing stresses. Okay, and medium column, that's we have already cleared these terms in the initial video lectures, right? I hope you understood this particular concept, and in the next lecture, we will solve some of the numerical problem onto these formulas of the stresses developed onto the extreme fiber, right? So thank you very much for attending this. Thank you.